Okay, in this video we're going to be carrying on where we left off pretty much in the last video. We're continuing our little exploration of the world of matrices, this crash course of matrices. Now in the last video I talked about the basic kind of matrix algebra, the basic operations that we can do with matrices. We can add, we can subtract, we can multiply, and the next operation would be, in ordinary numbers, would be division. Now with division of matrices we don't really treat it as division as such. We have to be very careful about how we think of it. Now, to explain what I mean, let me just consider this, 6 divided by 2. Now, one of the ways that we can think about this is we've got 6 of something. Here I've got 6 objects, which I've represented by circles. And I want to divide it or split it up into groups of 2, into pairs. Okay, so I simply go 1, 2. Okay, so there's one pair. And there's another pair here. And there's another pair here. So how many pairs have I got in total? I've got 3. So one of the ways that we can think about division is as simply splitting something up. Okay. Now if we think about division as splitting something up, so here we had 6 and we split it up into 2s. If you think about in terms of matrices, it's a little bit more. It's near impossible. You know, you've got a matrix and then you split it up. And how do you split it up? Well, you split it up by another matrix. It kind of doesn't make sense and it gets really difficult to think about it like that. So thinking about division as splitting something up with matrices, it doesn't work. So we have to think about it slightly differently, because one of the ways that we can also think about division of real numbers is as the multiplication. So we've got 6 divided by 2 as the opposite process of multiplication. So you have 6 multiplied by something else. Well, we multiply by the opposite of 2. Okay, and the opposite of 2 is the inverse of 2. And the inverse of 2, of course, is a half. Okay, so division is multiplication of the inverse. Right, so here we divide by 2, here we multiply by the inverse of 2, which of course is a half. Okay, and that is still 3. So we've got 6 over 2, that's 3. Okay, so if you think about division as the multiplication of the inverse in matrices, suddenly it makes sense because we can do multiplication, but we need to be able to find an inverse. Well, in most cases we can find an inverse, and here's what the inverse is. So say if we have a matrix A, and we want to find the inverse of that, well, we find the inverse by multiplying this altered matrix. This is A, and we alter it slightly. How do we alter it? We flip the elements of the leading diagonal, and we negate the elements on the other diagonal. Okay, and then as kind of a correction term, we multiply by 1 over the determinant of this matrix A. Now determinant, well, what is the determinant? I think of it as a cross. So say if we've got a matrix, we multiply the elements on the leading diagonal together, and we subtract the multiplication of the elements on the other diagonal together. Okay, I'll show you a little bit more what we mean by that. But one of the useful properties with determinants, so if the determinant is equal to 0, when we say that's singular, what do we mean by that? I think that's too many words. We say that's singular. And what do we mean by that? Well, we say there's no inverse. If it's singular, it's on its own. So there's no inverse which exists. Like here, the inverse of 2 would be minus 2. So it's kind of like they come in pairs. The opposite of 2 is minus 2. So it's a nice pair. But if we say it's singular, then there's no inverse which exists. Well, why? Because if you look at this thing, the inverse is 1 over the det of A multiplied by the altered matrix. Well, if the determinant of this matrix A is 0, then it's going to be 1 over 0, which is infinity. So we're multiplying by infinity, so therefore this matrix over here will basically come out as infinity also, which implies that there's no opposite matrix of A. Okay, there's no inverse matrix of A. But if it's not equal to 0, then we say that's non-singular. So in other words, there is an inverse which exists. So we can very quickly tell whether there is or whether there isn't an inverse which exists. Okay, and I think, you know, I've talked enough sort of in general terms. I think now's the time to jump into an example. Hopefully all that will become clear. There's quite a lot of ideas there. Okay, so if we have a matrix B, okay, and the matrix B is given by 6, 3, minus 2 and 1, then we want to know what the inverse of B is. Well, first of all, we have to know what the determinant of B is. Okay, we need to determine whether there is actually a 0 or not. we need to determine whether it is actually an inverse or not, so whether it is equal to 0 or not equal to 0. If it is equal to 0, then there's no inverse, and there's no point carrying on any further. No point doing any more work. If there's not equal to 0, then there is an inverse which exists, and therefore it's worth carrying on. So the determinant of this matrix is these two elements multiplied together. So it's 6 times 1 subtracts these elements multiplied together. So 3 multiplied by minus 2. Okay, so 6 multiplied by 1 is 6, minus 3 multiplied by minus 2, well that's going to be minus 6, double negative, it's going to come out as 12. Okay, so 6 plus 6. Okay, so we note the determinant, so the inverse is going to have 1 over the determinant of this matrix, and the determinant of this matrix is 12. Okay, and then what do we do to this matrix? We flip the elements on this diagonal, so the 6 and the 1 change places, and we negate the elements on this diagonal, so 2 and minus 3. Okay, and there we are, there's the inverse. Now remember, this is a scalar, this 1/12 is a scalar, so we can multiply this scalar through by every single element, this scalar multiplication. So end up with 1/12 minus 3 over 12, that's a quarter, isn't it? Then we've got 2 over 12, well that's a sixth, isn't it? And then we've got 6 over 12, well that's a half. Okay, so there's the inverse matrix. Now, why is that useful? Well, let's say we have, we want to, we have like an equation, I don't know, something like B equals A, okay, and we want to find out what this matrix A is, I don't know. Well, one of the ways we can do that is multiply by the inverse. Remember, when we multiply by matrices in matrix algebra, we always stick the thing which we multiply by out the front. Okay, so the new thing we're multiplying here is B inverse, so we have to stick it out the front, because of course B multiplied by B inverse is not equal to B inverse multiplied by B. So we have to make sure that we stick the thing which we want to add to it, the thing which we want to multiply by, our multiplier, we want to stick it out the front, and that's the same on both sides. Okay, and what is B inverse multiplied by B? Well, that's the identity matrix. Okay. Why is it the identity matrix? Well, here's where it's useful to think of a real number. Let's say, let's take 5, like we did in a real example, and represent it as a matrix. Okay, so 5. So here it's useful to think about 5 as a matrix, 1 by 1 matrix. Okay, well, what's the inverse of 5? Well, it's 1/5, isn't it? The inverse of 5 is equal to 1/5. Okay, the inverse matrix of 5 is 1/5. Okay, and what's 5 multiplied by 1/5? Well, it's 1, isn't it? And 1, if you like, is your identity matrix. 1 by 1 identity matrix. Because, of course, identity matrix is all the leading diagonal is 1, and all the other elements are 0. Okay, so it's a 3 by 3 identity matrix. 2 by 2 identity matrix as it will be here, because of course B inverse is B is a 2 by 2 matrix, and A is also a 2 by 2 matrix, maybe. Actually, it doesn't matter as long as the dimensions work, so that we can multiply. But we're going to end up with identity matrix of 2 by 2. Okay, so yeah, so this is all identity matrix. Basically, the leading diagonal has to be 1. Okay, it's the equivalent of 1 in the real numbers. Okay, that's what I'm trying to say. Whilst we're here, actually, it's useful to pull up another point. So we've got that if you have a matrix B and we multiply by the inverse of that matrix, then that's always going to be I. So if we have B inverse B, that's always going to be the identity matrix. Another useful property that we have is, say if we have A multiplied by B and we want to find the inverse of all of that, so we multiply A by B, we want to find the inverse of all of that, the resulting matrix of AB, then we can actually do it as just finding the inverse of B multiplied by the inverse of A. So in other words, we flip these two numbers and we just find the inverse of each of those, and then multiply them together. So these are kind of your two crucial ideas to do with division of matrices. Really, it's multiplying by the inverse.